Hey guys, so welcome to this quick Rhino and Grasshopper tutorial. In this example, we will be modeling a speaker perforation texture. We will start by making the outer curves in Rhino, and then we will distribute the texture using Grasshopper. And finally, we will bake these textures back to Rhino for the Boolean operations. Okay, so let's see how we can recreate the speaker grille texture. Let's get started. All right, so let's open the first Rhino file. You will notice that I have already imported the image, okay, which contains the texture reference. And this is just a sample part for the car door. So we will use the image as a reference to make the curves and the texture. And then we will transfer the texture to this poly surface geometry. Okay, so let's see how we can do that. So to create the curves, let's first go to the front viewport. Now you can see the car body behind the image. Let's go to layers and hide the body layer. In order to make the curves, I will activate the step 1 layer, and let's go to the curve through control point command. I'll use a curve of degree 3 and start making the outline shape. So I'll make a couple of points, 1, 2, 3, 4. You can select the curves, and then you can select the individual control points, and then you can move them around to fine tune the shape. I'll add another curve here, 1, 2, 3, 4. If you can see that the shape can be made with only 3 points, you can just select a point and delete the extra point. Okay. I'm also making sure that the curves intersect because later on we'll be trimming the curves. And lastly, let's make one more curve for the bottom part. Okay. So take your time to fine tune the outer shape. Okay. So now let's go to the next step. If you go to layers, I have already made a step 2 layer. So if you unhide it, you can see another geometry here. Okay. And what I'm doing here is that I'm moving everything by 200 units in the z-axis. Okay. So imagine if I would have made a shape here and I want this exact shape in the same reference point, but with this image, I can just select the geometry. Okay. Using the gumball, click on the arrow and set the distance to -200. And you can see now we have the geometry in the exact same reference point. Okay, so these are the outermost curves. Every time you want to center your camera to the object, you can select the objects and press this button, which is going to zoom to the selected object. Okay, so once we have made these curves, now we have to make the internal curves as well. So another set of curve will define the outer part of the handle, the inner part of the handle, and then this part, which is in between, and that is going to define the height of the handle. Okay, so let's make these additional curves in a similar manner. Now I have already done these steps. So if you go to step 3 and unhide it, you can see the additional curves. I have also color coded it, so it's easy for you to distinguish between the 4 sets of curves. Okay, so the red one is the outermost, the blue ones are the outer of the handle, the magenta one is the internal curve of the handle, and the green curves are the height of the handle. Okay, you can select these curves, enable the trim command, and click on the external part of the curve to trim the axis bits. So let's say if I select all of these curves, turn on the trim command, and I can now click on it to delete the axis parts. Okay, so you can slowly calibrate the internal curves as well. So once this is done, the next step is to create the blend between the 2 curves, okay, because we have these sharp corners. In order to do that, you can make some points. For example, if you want to trim the curve here and here, okay, so I've already made these points for you. You can enable the split command, select the curve, press enter, select these points and press enter. This way you can see we have trimmed the axis part. So if you go to step 4 layer, you can see I have trimmed all the curves for you. Okay, now let's bridge the gap between these curves. Okay, so you can bridge the gap by running blend curve command. Okay, you can also run the same command by going to curve tools, and here you can see the adjustable curve blend command. So let's click on curve A, curve B, and here you can choose the continuity criteria. We will go for curvature G2 continuity. You can further click on these points and fine tune the shape. Once you're happy with the results, press OK. Let's repeat the command. curve blend or blend curve. Click, click, and again define the shape. So if you zoom out a bit further, here you can see that I have blended all the curves, including the internal curve sections. And I have also made a circle to define the area where the perforation go through the entire width of the part. Okay, so if you zoom out furthermore, the last step will be joining all the curves together. So let's select them all. Again, press join. Okay, you can also select everything and press join. Okay, so these are the final curves. I have also color coded them, so it's easy for us to identify which curve we are dealing with. All right, so now let's see how we can transfer these curves to the part, first to make the handle, and then using Grasshopper, how can we add the textures. So let's unhide step 5. Okay, you will see the car body. I have also isolated the red curve. Okay, so I will be projecting this curve to the poly surface. Okay, you can also go to the parallel viewport to see the object in 3D. Now, in order to project the curve to the part, we'll be using the project command, curve from object, project. You can also run the project command here. Now, be very careful because some of the commands in Rhino, they depend on your viewport. So if you're in the parallel viewport, you wouldn't be able to project the curve in the y-axis. Okay, so first go to the front viewport and then rerun the command, project. Select the curve, press enter, select the poly surface, press enter. So now you can see the curve has been projected to the part. We will use the curve, okay, and we will be splitting the poly surface using the curve. Okay, so let's run the split command, poly surface, press enter, curve as the cutter, press enter. Okay, so this is gonna trim out the axis parts. All right. Anytime you're unable to zoom to the selected object, you always have to select the geometries and rerun the command. Okay. This is very useful because if you are trying to zoom to certain areas that is not selected, it's not going to be easy because the object is not centered on the camera. Okay. So always select the object and press zoom selected. Perfect. So as you can see, I have already isolated the part. And I have also pulled the other curves. This is easily done by moving these curves 200, 400, 600 units. Okay. Now let's see how can we project these curves to make the handle. All right, so let's rerun the project command. Now be careful. You have to be in the front viewport. Sometimes the camera is not centered on the area where you're working. So it's easy if you zoom out completely and then zoom into the area where we are working with. So let's select the curves. Press enter, and we would like to project it on the poly surface. Press enter. So if I zoom out or go to the parallel viewport, you can see the projected curve. So now let's see how can we create the handle with this. Let's go to step 6 and unhide the layer. Okay, you can see I've already projected the curves. Okay. After that, let's split the poly surface using the outer and the internal curve. So this is gonna create this intermediate section. After that, I will move this green projected curve by -10 units. Okay, so it's the height of the handle. So let's click on the gumball. If you don't see the gumball, you have to enable the gumball by selecting this option in your Rhino interface. So let's click on the arrow, -10. Okay, so how are we going to now make a surface using these curves? Okay, so what I can do is make some intermediate sections and then we can sweep those sections around these two curves as rails and then the sections as cross section for the surface. Okay, so if you zoom out, you can see I have done those steps. Okay, so here are the curves that we projected and moved. Plus these are the lines that you can make to connect the cross sections. It's easy if you look at it from the front viewport. Because imagine if I have to make the cross sections. Let me delete these surfaces. So these are the 3 curves. Okay. So I will run the line command and connect maybe somewhere in between here to here. Same here. Just define the distribution of the isocurves by creating an assisting cross section profile. We can do the same thing for the other part. Okay. Something like that. You can fine tune these settings. So I've already done these steps for you. Let's go to parallel viewport. Let's zoom into this section. Okay, so let's run the sweep command. So let's go to surface creation tool, sweep to rails. This is rail 1, rail 2, cross section, cross section, cross section. Press enter. Okay, and it's gonna pop up this window. Be very careful when you run the sweep command. It asks you to select the first rail. So when I select it, I don't need to press enter or select any of these options. It will automatically move to the second rail. So let me select the second rail. Then it will ask me to select the sweep shapes. So let's select 1, 2, 3, and press enter. It's going to pop up this window. And as you can see, in our case, we want the starting and the end section to be closed. So there is this option to select a closed sweep. Press OK, and there we go. So let me repeat the process, but using now this green curve and the magenta curve as the two rails. So let's rerun sweep 2, select the rail, the curve, the magenta curve, and then the cross sections, the red curve, this one, this one, this one. Okay, make sure to select closed sweep, press OK. So now we have these two geometries together. Further, I can select the intermediate cutout shape, and together we can join everything in a single poly surface. Okay, so let me show you how. So this is the two sweep shapes. This is the cutout shape. So let me move it by, I think, 10 units or 20 units. Okay, so we can join 1, 2, and then the third shapes together into a closed poly surface. Okay, all of these internal lines that you see, these are iso curves. We don't need to see them, so let's go to settings, properties, hide iso curves. Okay, so we don't need to see it anymore. All right, so I have assembled everything together. Now, if you want, you can also apply fillet to these parts. Solid, fillet. Okay, and you can define the radius, maybe 0.5. Select the edge. You can double click to chain the edges and press enter. Okay, so that is the final part. I've already made it for you. You can zoom into this section, and you can also run this command called emap. This helps you highlight an environment map on the part, which is going to give you a better visualization of the surface that you made. Okay, you can also choose different options from here. All right, so now let's see how to create the texture. All right, so for the next step, let's go to layers and unhide the grasshopper layer. Okay, if you zoom out, I have isolated everything else. Okay, so we have the outer curves. Okay, we have also these lines that I will use to make a surface. And using that surface, we will be distributing these frames in Grasshopper. Okay, so let's see how we can do that. The first thing you need to do is launch the Grasshopper interface. And you can do that by clicking on the Grasshopper button here or writing the Grasshopper command. So let's write the command and press enter. It's going to take a couple of seconds to load the plugin, but once it's done, you'll be seeing a floating window on top of your Rhino screen. So once you get the Grasshopper window, generally the configuration is half of your screen is Grasshopper and the other half of your screen is Rhino. Okay, so I don't want these additional parts hidden behind my Grasshopper window. So let me extend it around here. Now I can completely see what's going on in Rhino as well as in Grasshopper. Okay, so using Grasshopper, we can now create an algorithmic pattern that is going to take these two curves as the input, make a surface in between, use the surface to distribute a texture, and then we can also change the radius of the circles in an interactive manner using the attractor workflow. Okay, so let's see how we can do that. The first step is to import these two curves inside Grasshopper. In order to do that, let's go to the first tab, params, first subtab, geometry, and make two curve containers. So let's click and deposit in the canvas. In order to reference that curve, you have to right click on it, select one curve, and select that curve from the list. Similarly, let's make another curve container, right click, set one curve, select it in the Rhino window. Now we have these two curves imported successfully. You can also verify it by clicking on the node. The node turns green in color, so does the geometry. Okay. The next step is to loft the two curves. So loft is a type of surface. Let's go to Surface tab, Freeform Surface, and here you can find the loft command. Okay. You can also look for these commands by double-clicking on your interface and typing text. Let's say LOFT. So you will notice we can also create the loft command by writing and searching here in the Grasshopper interface. So now let's connect the curves to the curve input. Let's drag a cable. So click and drag and connect it to the curve input. Now you will notice that the command turns red in color. And this is a Rhino 8 feature. In Rhino 7, it doesn't even show you a red color. But what's going on here is that you are only connecting a single curve and you cannot loft only one curve. You need at least two curves. So in order to connect the second cable, you have to press and hold Shift and connect. Okay? Because if you try to just connect it, it will replace the previous cable. So let's press Shift and connect. Now, once we have the surface, we will be distributing a set of staggered panels using the Lunchbox plugin. So let's go to the Lunchbox tab, Panels tab, and here look for Staggered Quad Panels. Okay, it has three inputs, the surface, okay, and you also need to define how many subdivisions you want in the U direction. So double click and write 58 and press enter. So it's going to create a number slider of that amount, and 24, press enter. Again, these are some numbers I am using, but you can of course change them to fine-tune the texture. Lastly, we actually don't need the surface itself. What we need is the centroid of these surfaces, okay? And you can find the centroid by calculating area of these panels, okay? So now we have these points as a placeholder where we can create the texture. Always remember, in Grasshopper, it's very important to hide the previous steps. So what you can do is select all the nodes, middle mouse button, and then disable the preview. This way you don't see the effects of the other node, okay? So as you keep on building the script, you have to hide the previous steps. So now let's see how can we get rid of the points that are outside of this curve, okay? In order to do that, we have a special command in Grasshopper. You go to Curves, Analysis, Point in Curve, okay? We will use this curve as a reference and get rid of everything that is outside of that curve. Okay, so let's import that curve in Grasshopper. We will use a curve container, right click, set one curve. Let's select the curve. Okay, let's run the command point in curve. Now, before I separate the points, I would like to leave a bit of margin. As you can see in the reference image, we don't want textures here. So I'm going to offset this curve a bit inside. Okay, so let's go to Curve, Utilities, Offset Curve. Select the curve. Now by default, it's offsetting outwards. So let me offset it inwards by connecting a negative container. Okay, and the distance is going to be 4 millimeters. Okay, so these are the centroids that we would like to evaluate. This is the curve that we offset. Again, this is going to determine the relationship, that is whether the point is inside or not of that offsetted curve. Now we have to use a command called dispatch to filter the points. This command in itself is not going to separate the points that are inside and outside. It just creates instructions, but the dispatch command is the actual command which filters the points. So we have two outputs. Now, in order to see the result, as the command shows you both outputs in the same component, you won't be able to see the difference. Let me hide everything. Okay. And at the end, connect a point container. If you connect it to the B output, you will see all the points outside of that offsetted curve. And if you connect it to the A output, you will see all the points that are inside of the curve. Okay, so these are the points now where we will make the pattern. Now, if you see the image carefully, okay, let me hide this for a moment, you will notice that the density of the texture is not completely full all the way till the end. Okay, so it starts densely packed, but as you go towards the right side, you will notice that the patterns are randomly removed. Okay, and it increases as you go beyond that point. So let's see how can we get rid of some of these points in this random, non-random manner. Okay, so our list is arranged left to right. Okay, so the first point that you see might be here, second, third, fourth, all the way till point number 745. Okay, so in Grasshopper, we have a component called Jitter. What this component does is it takes a list and randomly shuffles the order. Okay, so now it's randomly arranged, not left to right. Okay. However, it also accepts a value in the jitter input. So if you set this number, let's say 0.5, the randomness is 50%. Okay. You can read furthermore what this formula looks like by going to settings. But yeah, in our case, we will just set it to a lower number and fine tune it. Okay. Now it has just randomly shuffled. That doesn't isolate these parts, these points. So what we are going to do is that we will select, instead of these 745 points, we will select the first maybe 300 or 400 or 500 points. Okay, how? Let's go to sets, list, and we will split the list. Split the list of 745 points at maybe 400 index. So in A output, you will see the first 400 points, and in the B output, you will see the remaining points. Similarly, you have to hide everything, connect a point container, and you can see the remaining point to the output. Okay, so let's fine tune it. How many points you want here, you can decide, and how much random and non-randomness you want, you can decide here. I'm going to set this to 0.25 and 470. Okay, so this is the configuration that we will use to distribute the pattern. Now, once we have the points, okay, let's create circles on these points. Okay, the problem with the circle component is that if you provide just a point instead of a plane, it will make the circle oriented in the X and Y axis. Okay, we want to orient the circles on the X and Z axis. So let's make a plane on X and Z plane on these points. Okay, and make the circles there. You might see the planes at different sizes because of some display setting in your Grasshopper interface. Okay, nonetheless, planes are infinite. You can just hide the inputs. Okay, so now we have the circular pattern, and you can define a radius amount. Okay, the problem is these radius amounts are uniform for all the circles. Okay, so now let's see how can we make the radius faded from left to right. So what we will do is measure the distance between these points and this curve. Okay, so let's look at a command called curve closest point. This will take in the points. Let me import that line in a curve container. Okay, and what it does is it pulls these points in our grid to the curve, and in the process it measures the distance. Okay, now once we have the distance, we can use the distance for the radius value, but you can see the raw distance value is a lot. So the easiest way to calibrate it is by multiplying it with a small number, maybe 0.250. And you can see this is a simple way where we can fade the pattern. Okay, make sure to hide the previous nodes. Now, this is not a precise way to control, and furthermore, we want the effect to be inverted. So what we will do is use a command called Remap Numbers. So Remap Number will take a raw set of distance value. It needs to know what is the highest and the lowest distance value, which you can find by using a component called bounds. Okay, so in your list, the lowest number is 16 millimeters, highest number is 188. And it needs to know what is the lowest and the highest number that you want for manufacturing. So let's go to domain, construct domain. So here we can define, let's say the lowest number is 0.500 or the highest number is 1.700. Okay, so every number has now been squeezed between these two sets of numbers. And now we can use it as our radius value. In our case, the effects should be inverted, so you just have to invert the connection. You can, of course, fine-tune the radius value for the minimum and for the maximum. So no circle is larger than this amount or smaller than this amount. Okay, so this is how we can fade the pattern for the perforation. So if you look at the texture closely, you will see there are three types of perforations. You will notice one is surface level. Okay, so it's just on the surface. It doesn't go through the complete part. Then these are the circles that go through the complete part. Okay. And these are the third type of textures, which are kind of like the intermediate. So we have the surface level plus the complete part as well. So now let's see how we can make these transferred to the actual model. So I will first start by making the complete perforation. Let's start by importing the circular curve that we have made. In a curve container, right click, set one curve. We will convert this circle into surface by going to surface, freeform, boundary surface. So it will take a planar curve and convert it into trimmed surface. Now we will trim this bigger circle with these smaller circles. Okay, so let's go to surface, mesh intersection, physical, split surface, surface to split, curves to use. Okay, so if you hide everything, you will notice it has split the surface using these curves. Now it's a bit difficult to see the effect. Okay, so what we will do is bake the geometry. So baking converts these grasshopper shapes into actual Rhino geometry. So you right click here, click on bake, and let's group it because we are dealing with a lot of perforations, and press OK. So you will notice now these perforations are baked into Rhino. Okay, let me just separate it for a moment. And you will notice that the bigger circle is there, but also the perforations. We actually don't need the biggest circle, so let me ungroup it and delete the excess part. Okay, we just want these cutout shapes, and we will use these, extrude it, and then perform Boolean difference. Okay, so let's see how to do that. So I'll minimize the grasshopper window, and let's unhide step 8 layer. Okay, so this is the geometry that I just baked. Remove the extra parts. We can extrude it, and in order to extrude these surfaces, you can click and drag using the circular handle, or you can also run the extrude surface command. Okay, so we have the extruded surfaces. Now let's run Boolean difference. Okay, remove the material from here using these shapes. Okay, now you can see we have the cutout part. Okay, I've also extruded the base geometry, okay, so that we have a bit of thickness. So that is the final output. Now, in order to create the trimmed surface level perforation, we have to go back to Grasshopper. So let me hide this component. Let me unhide the circles. All right, so now what we will do is project these circles to the poly surface. So let's look for the project command in Grasshopper, project curve. These are the curves. Let me import this poly surface. So we have to use a BWrap container. Right click, set one BWrap, and connect it here. Now by default, the direction for the projection is set to the Z-axis. Okay, so we have to change it to the Y-axis. So let's connect a vector in the Y-axis. Double click and write Y. You should be able to see this component. Connect it to the direction input. Let me hide everything else. Okay, finally, let's bake these curves. Group yes, please, and press OK. So let me move the curves in the Z-axis, -200, 4, 6, 8, 1000. Okay, so I'm intersecting the surface with these curves. So let's split the poly surface with these curves. It's going to take a while. And let me delete the excess part. Okay, so here are the trimmed poly surfaces. We also don't need the group of curves. You can delete those. So now we just have these small circular perforated surface texture. Okay, we cannot use these surfaces to make a 3D effect, so we will be extruding it to give it thickness. Okay, so just using the circular handle, we will extrude it by 1.5 units. So let's click there, 1.5, press enter. It's going to take a while. And now we have solid geometries that we can use for perforation. If you zoom out, I have done these steps, and I've also changed the color to green color and finally intersected it with the other part. Okay, the one where we had already these internal perforations. I've also removed manually the perforations that were complete, and I have also colored the perforations that were partially intersecting. Okay, so it's easy for us to work with them. All right, so now let's perform the Boolean difference one by one. Okay, now this operation can take a while, and also I don't recommend you to do all the Boolean difference together. Most likely it's gonna fail. Okay, so you have to do it in steps. How? So let's run Boolean difference. Select the object to remove from, press enter, select the object to remove with. Now, of course, I'm running it for a single geometry, and you can see it doesn't take that much time. But if I rerun the command, Boolean difference from here with all of these, it can take a while to calculate. Now, I would also recommend you to first perform the Boolean difference for the red sections one by one, because they are the Boolean differences that is most likely to fail. So Boolean difference with this. You can also repeat the last command in Rhino by pressing enter and then select and enter. So repeat the last command, press enter, okay, and repeat these steps. Here you can see the Boolean difference seems to fail. Let's try again. Okay, when this happens, you might want to increase the size of the perforation by a very small amount, okay? Or you might want to move it slightly, okay? Not that much. So let me scale it. Press shift and click, maybe 1/1000th of a unit. Very subtle scale. What this does is it avoids any kind of edge intersection which might be causing the issue. Now again, this is a very microscopic change. In the overall scale, you won't even notice what I have done. Okay, so once we scale, let's rerun the Boolean difference, remove from here with that. And now you should see it work. Okay, so once you have run the command for all the edges, you should be seeing a final output that looks something like this. So now let's go to layers and unhide the last layer. Okay, so let me position this object -200. So that is the final output. Okay, you can also save the Grasshopper file, save the Rhino file, and also go to the rendered viewport to see the end result. I've also made some materials in Rhino, and you can assign these objects these materials. Okay, so that is the final output. You can, of course, modify any of these parameters in Grasshopper. You can also change the panel distribution. You can change the random effect. You can change the radius value. You can also change the attractor curve to a different place. Feel free to modify these settings and create your own texture variations. All right, so I hope you were able to learn how to create these kind of perforation textures in Grasshopper. And it's quite easy to make these in Grasshopper, as you can modify these parameters and fine-tune the effect rather than manually modeling it. If you're using some other CAD package like Alias, Fusion, Plasticity, SolidWorks, you can of course import these models in a step file format, apply textures, and export it back to your native CAD package. So it can be perfectly integrated to your existing CAD tools. If you'd like to learn more about these texture workflows, you can check our learning resources, free webinars, and our live workshops. In our live workshops, I'll be there teaching you step by step how to create these and way more complex textures using Rhino and Grasshopper. For more information, you can check our webpage. Link is in the description. All right, so thank you all for joining till the end. Good luck with your projects, and I'll talk to you guys in the next tutorial. All right, bye. Take care.